Good evening, everyone. So, can we all hear me? If you can hear me, just all right. Thank you. Okay. Let's wait for maybe 1 minute before we start. Let's wait for probably 1 minute for others that are joining us. I want to let me launch Jupyter Notebook. So let me make these few announcements before we make a start. So next week is also going to be a Friday. So kindly bring your questions. Kindly bring your questions. If nobody has question, I have what I want to teach. So even if nobody have any question, I have what I want to teach. But kindly bring your questions next week, because next week is going to be the last class. So I'm going to entertain questions from everything that we have taught on the past 6 weeks so far. So I'm going to entertain questions on it. So kindly bring your questions so that we can sort it out. And I'm going to also give us the projects, hopefully this weekend or maybe on Monday, the latest. Let me share my screen. Can you all see my screen? Can you see my screen? No. Can you see my screen now? Can you see Anaconda? Okay. When the person said no, like I was shocked. All right. So yes, last week we did something on Matplot. So this week we are going to do something on Seaborn. So this week is going to be on Seaborn. And we can work with Matplot without having to do with Seaborn. However, you cannot work with Seaborn alone, especially if you want to give it title. If you want to give it title and the likes, you can't work with Seaborn alone. If you want to give it title and the likes, you can't work with Seaborn alone. If you want to give it title, if you want to give it show, all those things that I taught you last week, figures, but you can actually work with Matplot alone. But you can't work with Seaborn alone if you want to make your coding to be easy. So we used the data we used last week. It's still the data we are going to use, and the name of the data is fake employee data set. Fake employee. So let me import pandas as PD. At least we are used to this. We know that. And import. I've taught you NumPy. We might likely use NumPy as well. So import NumPy as NP. So that was why I taught you NumPy first before we started the visualization. Then import Seaborn as SN. Let's use SNS. some people use SN, but let's use SNS. Then imports Matplot library dot pyplot as PLT. So as good practice, just like I've taught us, this is importing all the libraries. That's importing all the libraries. So let's import the data sets that read CSV dot CSV. So this is our data set. We did this last week. So I believe that we are already used to it. And last week we did more of bar charts and the likes. So today I want to do a bit of some other plots that we have and that you can use. However, let me be more sincere with you. However, if you are working in an organization, most of the plots that I want to plot for you today, you might not really be using them. And I will explain why. But because some of it are not well, they might not fit what you want to use it for. So the best thing is to use a figure. What's the essence of using a figure that your stakeholders will not understand? Then it's not, then that's not okay. It's not okay at all. Using a figure, drawing a figure that your stakeholder doesn't understand. So that's not okay at all. However, it is needful that you know it and you know how to actually draw it. So like I said, we are going to make use of Seaborn. Like I said, we are going to make use of Seaborn and Matplot library together today. We are going to make use of both together. So what I want to draw now is a box plot. Is a box plot. I work in an organization where we produce a lot of figures, but we don't use box plots. That's what I'm telling you. So because I received some messages last week that, it was only bar charts that I demonstrated and stuff like that, and I didn't demonstrate the others. Now, it's good that you know the rest, but I'm just telling you that if you are really working in an organization, there is 90% possibility for some of you that you are working as a data analyst, you will testify to what I'm saying. You will majorly be using the line charts and the bar charts. If you are working in that where you use visualization, can you testify to it and say yes? Let me see if is maybe you can answer me that yes. Yeah, Damiloju is here now. Can you testify to it? I know you cannot speak. Just answer. Aha, yeah, thank you very much. So, but it's needful that, it's needful that you know it. It is needful that you actually know it. So I want to do a box plot, and the box plot of what I want to do, I'm going to be using the Seaborn. The box plot of what I want to do is the salary distribution by department. That is departments by salary distribution. I know that we used the bar chart for it last week. So we want to use a box plot for it. Now, already we know this, plt.figure. So let me make the figure equal to 8,6 Yeah, plt.figure. Then now you know that we have represented our Seaborn as SNS. So SNS dot box plot, xnx dot box plot. So now this is just the normal syntax of Seaborn. It's just the normal syntax of Seaborn. So don't forget that SNS is just the alias of Seaborn that we just created. So we are going to make our x-axis to be department. You know, why are we making our x-axis to be department? Because it is the what? The categorical variable. I think I explained categorical variable to us last week. Is the categorical variable. So we'll make our y-axis to be equal to salary. We make our y-axis to be equal to salary. And then we call our data. The name of our data is what? DF, which is the data frame that is there. So like last week that we gave our plot a title. So let's give it a title: salary distribution by departments. Salary distribution by departments. Then PLTS ticks. Don't forget that was for rotation last week. Rotation equal to 45. Then, like I said, but it's good that you always put it in case you are not working in Jupyter Notebook. So now this is the box plot for salary distribution by department. So, and of course, by this, we know that the highest department that is collecting money is finance. Like I said, this is a fake data. It's not a real data of any company. It's a fake data. It's not a real data of any company. So take note of it very well. It's a fake data. It's not a real data of any company. So you can inform your stakeholders, but this is too fancy. Like some people, some of the stakeholders will be like, what's this? But whereas they are more used to they are more used to the line chart and the bar chart. But I want to teach you so that you just know it. But know that at the back of your mind that if you start working as a data analyst, you will hardly use them. But it is needful that you also know them. You will hardly use them. Then, so this is a box plot, but now we make use of Seaborn. We didn't use the Matplot that we use, although we still use the Matplot for title, for rotation, and the likes. So let me continue. Then let's also do something on, let's use another plot, which is the peer plot. This is a peer plot, and I want to find a pairwise relationship among numerical values. So, like, what I want to do is I want to use, I want to make use of gender. So I want to find the distribution of gender in all the numerical, in all of the numerical values. So let me, as the name called, which is also, as the name has been called as peer plots, that's what I will also put. So SNS dot peer plots. So our data is DF, and what I want to use, that's why I call it U. So you can see that I am not typing the columns so that I won't make mistake. And it is case sensitive. Let me do something for you now. So let's say that if I should put this as a small letter G, let me run it. You can see that, what did he say? Although he still drew it, but he still gave an error, key error, gender. The reason being that I have not put is in what? Here is in capital letter. So it's what? Case sensitive. So if you have not taken note of that before, kindly take note of it. So let me draw it now. So as you can see, this is the key, like this is the legend, sorry. So for salary, now this plot is not well understandable enough. That's why we don't use it for stakeholders and stuff like that. It's not well understandable enough. So that's why we don't use it. But this is the distribution of female. But as you can see, we can still see that female has the highest distribution of salary, followed by male, and followed by non-binary. But there are some people that they have color blindness. So they might not be able to detect this very well. And that's why as for stakeholders, you don't use this for them. So if you scroll down, like I said, it's for numerical variables. And the numerical variables that we have are years of experience. These are the numerical variables that we have: years of experience, performance score, and salary. So if I can do the same thing for I can do the same thing for department as well, because it's also, department is a categorical variable. I can do the same thing for department. All I need to do is to change this gender to department, and it will do the same thing for me. So if I should do for department now, so the EU has to be a categorical variable. The EU has to be a categorical variable. I can do it for state too. Let's do it for state and not departments. So it has to be categorical variables. So we have a lot of legends here. You can see different ones. So here, as you can see, some people will have color blindness, and so they might not be able to understand, oh, this is the count of, but with the look of things, New York still has the highest salary, followed by Florida, but it's kind of difficult. It's kind of difficult to do. It's kind of difficult to do. So let's use another one. We call this one the count plot. It looks similar to bar chart, but in Seaborn, it's called the count plot. The count plot, and is the number. So what I want to do is the number of, let me look for one. Yeah, number of employees per state. The number of employees per state. The number of employees per state. So I want to know the number of employees per state. So how do I go about that? I think we did something on count plot last week, last week as well. What we just did we just counted it, we did not draw it, but Seaborn can allow for us to draw it directly. So SNS dot count plot. So our X equals to states. We want to know how many employees are in each of those states. We want to know how many employees are in each of those states. So our data equals to DF, and let's copy this up here. So to give us our title and our rotations. So we have the count, the number of employee per state. Number of employees per state. So for example, now, if you are asked by your stakeholders that can we do a row count? Some organizations do row counts at the end of every year. They do a row count, they do statistics of row counts of employees at the end of every year. So just for the stakeholders to keep them informed of how many female or how many employees from different states that are working in their organization. So this kind of plots can be useful. This kind of plot can be useful. So here now, we can see that Florida has the highest. So if I want different colors for it, then I will introduce something that we call palettes. So I will say palette equals to muted. Palette equals to muted. So palette is for color. I must have made a mistake in the spelling. So that will give it different colors. Yeah. So as you can see, it has given it different colors. So palette is just color. So when I say muted, just give me different colors. So you can see here that Florida has the highest number of employees, followed by New York, then followed by California, Illinois, and Texas as the last one. Let me see if there's any question. Do you have any questions so far? I see that somebody is typing. From last week. I tried to draw the bar chart through Matplot for last week. You should draw the bars. You should draw the bars. It should. I think I send the notebook if you follow what I did last week. But there's no problem. Let's use Seaborn to draw another bar chart. And let's do for let me teach you another method for how to calculate average salary, making use of NumPy. PLT. No, I think I know why it did not work. The reason why it did not work from what you have here is because you did not put DF in salary. That was why it did not work. You did not put DF in salary. You know, you put DF at the back of departments. You didn't put DF in the back of at the back of salary. That was why it did not work. Did you understand it? Do you get what? This is what you did. Let me type what you did here now. Hang on. Let me try to save it. And plt.figures. Let me try to put it here. plt.figures fig size 5.3. Okay, I'm not sure that I even need this. I think it's this that I want, that I actually need. plt.bar, plt.bar dot bar. So this was what you did. DF departments salary, then color equals to purple. So this was what you did. If we should run it here too, it will not run. It will not run. It will give us the same thing. But let me add DF here now. You can see. You can see that it has run. Can you see now? So you didn't add data frame. You didn't add your data to this. That was why it did not run. So I hope that is cleared now. I've solved that. Very good. So let me teach you another. Do you have any other question before I move on? It's because you did not put DF. That was why it did not work. If you put DF, it's going to work. So now let me teach you another way. Since I've already taught you NumPy, we did mean last week. So let's use NumPy to calculate our mean again. That's why I said there are different ways to calculate mean, and NumPy is also part of it. So let's use NumPy to calculate it. And what we want to draw is also a bar chart now. So let me copy this. And I want to calculate average salary. Let me just copy it so that don't need to be repeating myself. So I want to calculate average salary by departments. Average salary by department. So this is a bar plot now. So SNS.bar plot. Now I'm making use of we said average salary. Average salary means what? Mean. So estimator equals to NP dot mean. Now our NP is what? Don't forget NumPy. So the estimator that we introduced here is going to do the average mean of what? Of salary. That is what it's going to do for us. So here, let me change it to average distribution, average salary, average salary distribution. Yes, average salary distribution by departments. So I'm trying to tell you because I taught you NumPy before. So I'm trying to tell you where we can use NumPy again. So let me run this now. So you can see that we have the average mean, and it's still finance that is having the average, the highest average salary. Now, if I want the colors to change, I'm still going to make use of palettes, and I can call it another name. Instead of muted, I can say cool warm. The cool warm, what the cool warm will do is that it will make those colors to diminish. So, do we get it now? Any question? Any question so far? Any question so far from what we are doing? All right. So that is how to calculate the average salary distribution by departments, you making use of the NumPy. Don't forget that last week we just make use of the Matplot and we calculated our mean by ourselves. We didn't make use of this method. So that means there are more than 1001 ways of actually doing things. Then let's do something on scatter plots. Scatter plots. If you are going to do a scatter plot is always numerical variables against numerical variables. So if I want to do a scatter plot now, I can only do scatter plots. I can only do scatter plots of maybe salary against, I can only do scatter plots of maybe salary against performance score or salary against the years of experience. So scatter plot is always numerical variables. You cannot do scatter plot for categorical variables. So note that very well. Note that one very well. You can't do scatter plots for categorical variables. You can't do scatter plot for categorical variables. So PLT, let me copy that figure again. PLT dot figure. Then we have SNS dot scatter plots. So our X equals to years of experience. I want to do the scatter plot of years of experience against salary. So our X equals to years of experience. Now, you will only need scatter plots if you are doing regression, but we are not getting to that. So if you are doing regression, where you will draw a line of best fit and all those things. But it's also good that you know when you have numerical variables, when you want to plot two numerical variables together, you make use of a scatter plot. So a scatter plot will only give you, so here now, this is our X and this is our Y axis. So what I will use the categorical variable to do, I can't place a categorical variable in this X or Y axis. That's what I mean by that. So what I will use the categorical variable to do is to know how they are distributed. So let's make use of the gender as our hue. How are they distributed? let's make use of gender as our U, and our data equals to DF. And let's introduce the palettes already. And let me call this dark. So let me change this to years of experience. So this is our scatter plot now. That is our male, how they are scattered with salary, where they meet and stuff like that. The female, the non-binary. So this is how to draw a scatter plot in, if you want to, with the Seaborn. Do we have any other question before I move on? Any other question before I move on? All right, let me continue. Then let me also demonstrate how we can draw an histogram. If you want to draw an histogram, how can we draw an histogram? So histogram. So let's draw an histogram of the distribution, just like the word histogram. You know, histogram is different from bar chart. So distribution of years of experience. Let's do the distribution of the years of experience. So let's copy our figure. It's not compulsory that you use 8 and 6. So I've told you that deal. Let me even use maybe 12 and 10 now. You will see that the figure will be different. Let me use 12, 10. You'll see that it will be a bit bigger. But it's just because that's what I want to use. So for histogram, it's going to be east plots. It's going to be east plots. And we are going to have our, so since it's only histogram, we'll say DF into brackets years of experience years of experience, then PL title. We don't need rotation, so I'm going to delete that. So we just be years of experience. Distribution of the years of experience. So let's draw this. SNS dot east plots. No, that's the way it is. Oh, sorry, east plot. So as you can see, this is the distribution of years of experience. Now, of course, you know that histogram, the difference between histogram and bar chart is histogram are always together. As you can see, is together as well. So today, do we have any question? All right, so that means we all understood it. So today we've drawn different kind of charts. We've drawn the histogram, we've drawn the scatter plots, we've drawn the bar plots using the Seaborn, we've done the count plots, we've done the pair plots, and we've also done the box plots, making use of the Seaborn. So if you are doing visualization if you are doing data visualization in Python, the best is to combine Matplot and Seaborn together. That's the best. Combine the Matplot and the Seaborn together, and you will get good visualization. So, any other question before we wrap up the class? Somebody is typing. Okay, when I run it out, yeah, obviously, you have to run it before you can understand it better. That's obvious. You have to run it before you can understand it better. I'm coming. Somebody is typing. All right. While we are waiting for them to type, let me just give a brief recap of what we've done. So last week was Matplot. This week was Seaborn, and we represented our Seaborn as SNS. And we loaded our data. So we use the Seaborn to do box plot. And we also use it to do the pair plots. And I told you that naturally, if you are working in an organization, it's good that you know it, but you might not really use them. And we also make use of the count plots. We make use of the bar plots, and we also make use of the scatter plots. Now, scatter plots are meant for numerical variables, and we make use of the histogram. So somebody else is typing. Let me wait 1 minute before I wrap up the class. Okay. Now, the hue is like a legend. That's what it means. The hue is like a legend. Now, if you look at male is green. If you look at my screen very well, male is what? Is green. So that is the green that are scattered around. And female is green. That's the green that are scattered around. So we need a categorical variable as hue, which is also like a legend. So to know how they are scattered. But what I'm saying is you can't use your X and Y axis as categorical variables when you are drawing a scatter plot. That is what I'm saying. It has to be numerical variables. So, but you have to use a legend, a hue to know how they are scattered. So that will give you this. And that's why we have this. And non-binary, they are the blue ones. So you just want to know how scattered they are. And male, they are like this as well. So do you understand it now? All right, thank you very much. So with that, we come to the end of this class. And next week, like I said, bring every of your questions, and I'll be right here to treat them. So thank you very much. I'll see you guys next week, Friday. Thank you.